Okay, so let's look at 1.6. It's graphing the tangent, cotangent, secant, and cosecant graphs. What I want you to do first is look at your unit circle. And we have so far graphed sine and cosine. And if you're looking at your unit circle and your chart, I think if you go down the chart, you can kind of see that the sine starts at 0, goes up to 1, goes back down to 0, goes down to -1, goes up to 0. That's your wave. We were talking about that continuous curve for sine and cosine. The tangent graph, though, looks way different because there are some undefined areas in tangent. So if you go down, if you look at the tangent column, it starts at 0. So if you have 0 radians, your tangent value is 0. So your tangent is 0. But if you have 0 radians, you go to cotangent, that's undefined. Then you go down to 90 degrees, which is pi over 2 radians, and your tangent is now undefined. And your cotangent is 0, so they just keep switching. At pi, which is 180, your tangent's going to be back to 0, your cotangent's going to be back to undefined. I'm just looking at the axis angles, like when we graph them. Okay, all these other little fractions are going to graph when we see them on a calculator, but these are the axis angles that we can graph. 3 pi over 2, again, is undefined for tan. It's 0 for cotangent. 2 pi is 1 rotation. You're back to 0 for tangent. You're back to undefined for cotangent. Well, how do we graph undefined values? That's the key. That's the question. How do you graph values that are undefined? And the answer is you can't. You're not allowed to graph an undefined value. It's not defined. It is not a value. So we need to find out where our undefined values are on our graph. So tangent graphs are going to be undefined at pi over 2. Okay, that's where the tangent is undefined. And it's also going to be undefined at 3 pi over 2. So I need to find out, first off, if this is just x, we can just say x can't be pi over 2, and x can't be 3 pi over 2. Now I put x equals because what I'm trying to do here is I'm trying to find where the undefined values are. If x equals pi over 2, then you're going to have an undefined value. If x equals 3 pi over 2, you're going to have an undefined value. And there's a way that we put those on a graph. There's a way that we show that on a graph. And it looks like this. So let me show you here. So if I go to my graph, let's say this is 2 pi right here. And this is pi. And then this has to be pi over 2. And then this is 3 pi over 2. To show an undefined value, a value that you cannot graph, you simply make a dotted line vertically straight down through that value. What that dotted line is telling you is that you're not allowed to touch that dotted line. There's no values there. It's like a wall. You cannot cross over it. Okay, it's the same thing at 3 pi over 2. 3 pi over 2 is like a wall. You cannot cross over it. Well, let me show you Decimos really quick. I want to show you what tangent x looks like. Tan x. There it is. It's not a continuous curve because there's dotted lines that you can't see on this graph right now. If you look, you've got 0, 0 right here. Okay, you've also got this point, which is pi 0. But on the sides of pi 0, this green line can increase and increase and increase and go up, but it's going to come to a point where there's a dotted line that it can't cross over, so it just jumps over and it starts down here again, starts working its way back up. It just keeps jumping over the dotted lines. You're not allowed to graph on those dotted lines. So if you look at this little chart here, what is halfway between the two dotted lines? It's always a 0. Halfway between the two dotted lines will always be a 0. You can always bank on putting that dot right there. Okay, now tangent graphs, if you look at Desmos again, they go up on the right side of their graph and they go down on the left side of their graph. That's what tangent graphs do. Now that's where your amplitude comes in, where that would be like a 1. So if I was to go up 1, that means halfway between these two right here, I would go up 1 on the right, because it goes up on the right. And then halfway between these two, I would go down 1 on the left. So my tangent goes up on the right, it goes down on the left. But it is still a curve. You're not connecting dot to dots with the ruler. You're still making curves. You can see on Desmos, that's definitely curving the curved graph. So that's called your tangent graph. Now, you're not going to normally see that period on a graphed answer. What they're going to want you to do is show where it would be in the middle of the graph. So you see how this dotted line is pi over 2 units to the right? There's another one right here at negative pi over 2 units to the left. That would be another dotted line right here. That between those two is actually 1 pi. Between those two, between negative pi over 2 and positive pi over 2 is pi, just like between pi over 2 and 3 pi over 2 is also pi. So you can keep going another pi and another pi and another pi and make as many dotted lines as you want to. But they're going to want you to keep the graph centered. So they're going to want the origin to be your center point, 0, 0. And you can see that on this chart. At 0 radians, the tangent is 0. So 0, 0, this is like a coordinate right here if you put a comma between them. 0, 0 is on your graph. So that's what they're going to want. They're going to want you to keep it in the center. So they're going to want you to go up 1 here on the right and down 1 here on the left and make your curve like this. You're going to see it's an identical curve to the one we just did. It's just over 1 more different rotation, but it's in the center of your graph. They're going to want the graph centered. So in other words, instead of making it equal to pi over 2 and 3 pi over 2, what you're going to want to do most of the time is make it equal to pi over 2 or negative pi over 2. Both of those would be dotted lines. So would 3 pi over 2. That's also a dotted line too. But they're going to want you to keep the graph in the center. So I would put this above your tan. I would put pi over 2, negative pi over 2, because that's what you're going to make them equal to every time. So that was first one. Let's look at cotan. Cotangent. Now let me do one thing up here. Right above tan, I'm going to show you that this is the curve for tan. It goes up on the right, down on the left. Cotan is the exact opposite of that. It's the reciprocal, so it's the opposite. It goes up on the left, down on the right. What happens if you were to say put a negative in front of a tan? It would flip it over and it would look exactly like a cotan then. So a negative tangent is going to be the same graph as a cotan, and same thing with negative cotan. If you had put the negative in front of this cotan, it's going to flip it over. So you might want to write a couple of things up here. You might want to put its direction, just so you know in your head, okay, I know I need to go, that's the tangent, hold on, my bad. You want to go this way. Show its direction, it's going to go up on the left, down on the right. And you might also want to show where the undefined areas are. Because remember, there's some places you cannot graph. Like in this graph, we could not graph pi over 2 or negative pi over 2. Those are undefined. Where in cotangent is our undefined values? Do you see one right here? That's at 0. Do you see another one right here? That's at pi. That's going to be as centered as you can get. And notice again, halfway between them is always a 0. So 0 and pi are going to be your two values that are going to be undefined that you're going to look for. So above this, you got the direction. You might also want to put 0 and pi. That's what you're looking for. So x equals 0 is one dotted line. X equals pi is your other dotted line. And in this graph, there's no numbers in front of x, so it's already solved. But how do you make a dotted line at 0? 0 is my y-axis. Well, the answer is pretty simple. You just make the y-axis, make it a thick dotted line so you can actually see it. Just make it thick, and you'll know that that 0 is a dotted line. You'll know that your y-axis has to be an asymptote line. You're not allowed to use that. I don't think I gave you the name yet, did I? So let me do that right now. These dotted lines right here are called vertical asymptotes. asymptote. They are, I just call them vertical dotted lines, but vertical asymptotes are the lines that you cannot graph on. Not allowed to graph. It's like a wall there. You can't go through it, but you can go over it. You can jump over and go to the next one. You can't go through it. So 0 is one vertical asymptote or dotted line. And let's call this one over here pi. Could be the first one pi, whatever. You could go to 2 pi there. But let's just call that pi right now, just so we can draw a good graph. We're going to make a dotted line there. If that's pi, then the halfway between that would be pi over 2. And that's going to be a dotted an intercept. Always halfway between them is your intercept. So as soon as you find your 2 dotted lines, boom, right in the middle, put an intercept. And you know your cotan is going to go up on the left. So if I go halfway and up 1, that's going to be a dot on the left. And then halfway and down 1 is going to be a dot on the right. And that's a curved graph. It's a curved graph. So what do I look for when I grade that? Number 1, I look to see if you got the dotted lines right. If those are wrong, the whole graph's wrong. So that's, when I grade them on your next test, I just look, are the dotted lines right? So if they're not right, I don't even have to grade the rest of it. It's wrong. Okay, so you've got to find the dotted lines. So you're doing tan, cotan, secant, cosecant. All 4 of them have dotted lines because they all have undefined areas. If you look at the last 2 columns on your chart, there's undefineds on there. So you have to get the dotted lines first. I don't look at anything else. Then I have to see if you have the right intercept. And then I just look and see if you're going the right direction. I don't even care if it's not perfect. If as long as that's up on the left and down on the right for a cotan, I'm good. Okay, so you're going to see, make sure you get your dotted lines. Okay, let's look at tangent of x over 2. Let's see what happens when you take the x and divide it by 2. We know a couple things. Number 1, we know the direction for tan. Up on the left, down on the right. We know also that we need to find pi over 2 and negative pi over 2 as our dotted lines. So we got to take this value, x over 2, and we got to set it equal to pi over 2. And we got to set it equal to negative pi over 2. Okay, we got to know that that's where our dotted lines are going to be right there, pi over 2 and negative pi over 2. So we got to find out what could we put into x that would make a pi over 2, and what could we put into x to make a negative pi over 2? Because those are our dotted areas. So how do I solve this? You kind of don't even really need to solve this one, right? If you've got x over 2 and it needs to be pi over 2, then what does x have to be? What's going to make that equal pi over 2 is just a pi. If you put a pi in there, you'll have pi over 2. And then if you put a negative pi, you'll have negative pi over 2. So what I want to do is go over one line for pi, go over the other side for negative pi. Those are going to be your dotted lines. Basically, what we just did is we stretched the graph. This is a vertical stretch. This really means 1/2 x. It really means 1/2 x. And since this is less than 1, b is less than 1, we call it a horizontal stretch. Horizontal stretch. That means it used to be at negative pi over 2 and positive pi over 2 would have been our dotted lines, right? But now we're stretching it open to pi and negative pi. We're pulling it open. because it was less than 1. When it was less than 1, we stretched it. Okay, so halfway is always an intercept. You don't have to worry about it. There's 1 point right there. And then all you got to do is say, okay, I'm going to go up on the right. So halfway over is going to get me up to 1. So right there, I'm going to go up on the right side. And then halfway over here is going to go down to -1. And I'm going to go down on the left. You're done. So the main thing is get the dotted lines and get the intercept. And then go the right direction. Tangent goes up on the right, down on the left. And you'll have it. So you got to find where your dotted lines are. And for tangent, you're always going to make it equal pi/2 and -pi/2 because they want you to stay in the middle of the graph. So whatever is with x, put it equal to pi/2, put it equal to -pi/2 so you can find out where those dotted lines would be. And then you're either stretching it or shrinking it depending on what's in front of your x. All right, let's look at the next one. Oops. Let's look at the next one here. I think that's the next one, yeah. For -3 tan 2x, the same rules apply as sine and cosine as far as stretches and shrinks go. This -3 in front, okay, you see this right here? This is going to flip and vertical stretch. Okay, this 2 right here is going to horizontally shrink it. Because b is greater than 1, that would be a horizontal shrink. A is greater than 1, absolute value of a is greater than 1, that's why it's a vertical stretch. So what we want to do though is we want to take this 2x and we want to make it equal to pi/2, and we want 2x to equal -pi/2. We've got to find out where my dotted lines are. That's the main thing, the most important. Find your dotted lines. Okay, so we know that with tangent, normally I'd be going up on the right, but this one's going to go up on the left and down on the right because it's a negative. This negative sign is going to flip the graph over. And I know that for my tangent, I got to make it equal pi/2 and -pi/2 to find my dotted lines. So how do I solve that now? How do I get x by itself here? I could divide by 2. But then I'd have to divide fractions. Why don't you just multiply by 1/2 on both sides? You see what that does is it cancels out the 2's, doesn't it? So now you have x by itself. And when you multiply across, you get pi/4. And then if you multiply this one by 1/2, and this one by 1/2, you're going to get -pi/4. I would say 90% of the time you're going to get the same number with a positive and a negative value, but not every time, but 90%. So that means that the pi/4 is what's going to make us go undefined. If I plug pi/4 into this x right here, if I put pi/4 in there, it's going to equal pi/2, which is undefined. So I cannot graph that pi/4 value. This cannot be graphed. That cannot be graphed. So when I take my problem here, if I go pi/4 is really close, and -pi/4 is also really close, because it was a horizontal shrink. We already knew they were going to be close. So those are going to be the dotted lines. You just throw the dotted lines in there. Halfway between is my origin. That has to be an intercept. Now it is a flipped graph. It got flipped over. So we are going to go up on the left, and we're going to go up 3 units. And the halfway point is going to be up 3 units. And then this halfway point is going to be down 3 units. So you're going to go up on the left and down on the right. So it is a very skinny graph. graph because it got stretched and shrunk both. So very skinny graph there for the tan. But when we look at the chart, you see that there's undefined values on tangent. You can't graph those. You have to find your dotted lines. You have to find out where they are. So when you get to the next one, you have cotan, and it's a positive cotan. So I know my direction. You have this on your link. If you want to use your phone or whatever, you can just go to the link. But it's going to be this direction because it is a positive cotan is up on the left and down on the right. And I need 0 and pi here because those are my dotted lines. So I need this x over 3 to equal 0, and I need x over 3 to equal pi. I need to find out what could I put in for x to make a 0 come out, because that's dotted. What could I put in for x to make a pi come out, because that's also dotted. Now this one's easy to solve because if they're dividing by 3, you just multiply both sides by 3. X is still going to be 0. 0 times 3 is still 0. So your first dotted line is actually going to be the y-axis. So you can just make the y-axis a dotted line. I just make it thicker so I can see it. That's one dotted line. If I solve the next one, I multiply by 3 on both sides. Your other dotted line is at 3 pi. So it got stretched. It got pulled open. Instead of only going to 1 pi, it's actually going to 3 pi. It's 3 times bigger because they put a small number in front. This right here is the same as 1/3 x. So your B number, B is less than 1, that would be a stretch horizontal. And hopefully you see it because it used to be 1 pi was our dotted line. Now it's all the way going over all the way to 3 pi. So let's say this was 1 pi, this was 2 pi, 3 pi is way over here. What's halfway between 0 and 3 pi? That's your intercept. Halfway between 0 and 3. 1.5. So you got to go to 1.5 pi, which you could write as 3 pi over 2 if you want. That's the same as 1.5 pi. That's not a dotted line. That's your intercept. And since it's a cotan, and our number in front's a 2, you could go up 2, and you're going to go halfway, which is not at the 1 pi. It's inside of that 1 pi. It's probably like that area. That's going to go up to 2. And then the other side, the right side, is going to go down. So you're looking at right around in there, down to -2, down here. So -1, -2. And there's your stretched a little bit, stretched vertically. You're going up on the left. You're going down on the right. And a little bit stretched vertically and a little bit stretched horizontally. And it has to go up on the left, down on the right because it's cotan. And on Desmos, you can kind of see them. The tan has got as many of these curves as you want to go around the circle. And every time it comes to an undefined area, it jumps. Jumps to the next cycle. And then it jumps to the next cycle, and then it jumps to the next one. So that's tan of x. What I want to show you is cosecant of x. Don't freak out. It's not as hard as it looks. Now let me show you cosecant x. So if you look at that, there's cosecant x. It's a lot of u's and a lot of n's. But watch what happens when I put in sine of x. Because aren't those reciprocals? Isn't sine of x the reciprocal? Watch what happens. It's a perfect fit. So even though your answer is only going to have u's and n's in the book, what I would suggest you do is draw the sine curve first. Because that shows you where the u's go and it shows you where the n's go. And we only do one rotation. So really on your answer, you're going to have one bow tie right here. And then you're going to have one u and one n. Right where the top of the sine curve is, you'll have your u shape. And where the bottom of the sine curve is, the minimum value, you'll have an end shape. And you can't see them, but there are dotted lines between them all because there's undefineds on the chart. You look at that last column and secant or cosecant, there's undefined values. So if you're graphing cosecant x, don't graph cosecant first. You won't know where it actually is. What you should graph first is y equals sine x. Just graph its reciprocal first. Get where the curve is. Get where the wave is first. So to do that one, we've already learned this one. You find your amplitude, absolute value of 1, which is 1. You find your period. 2 pi divided by whatever b is. And b in this case is a 1 because that's in front of x. So 2 pi divided by 1 is just 2 pi. So my 1 period is going to go over to 2 pi. And here's pi, that's halfway. Half of this would be pi over 2. And then half of this one would be 3 pi over 2. Those are the axis angles. We have 90 degrees. We have 180. So 90, 180, 270, 360. So we could put degrees into there if we wanted to. But it's a bow tie graph. I'm going to get rid of that 1 there, but that's how I got that B. But this graph right here is a sine graph, which means it is a bow tie. That is important. The reason I write bow tie is because that tells you it's got 3 intercepts. A beginning, middle, and end, because you need a knot in the middle of your bow tie. So you've got a beginning 0 and middle 0 for your knot, and then you got an ending 0. And the amplitude is up 1 and down 1. And its maximum goes first, unless it's negative, which this one's not, and then its minimum goes next. And you draw this in. Now I'm going to draw this in a different color. You might draw it in as a dotted line. It's technically not your answer. Okay, that's not your solution. But it gives you the solution. It gives you everything you need. Do you see the 3 dots in the middle? Those are now dotted lines because the reciprocal function says that wherever a 0 is, when you do a reciprocal of it, that's undefined. So if sine is 0, that means cosecant is undefined. It means you can't have the 0, you can't have a pi, and you can't have a 2 pi. Because those would all be undefined areas. Wherever there's a 0 for sine, that's an undefined cosecant. And then the top, wherever there's a maximum, just draw in a U. I don't care, just kind of fill up the 2 sides. That's all you need to do. And wherever there's a minimum, you're going to make an N. And that's it. You need to just graph the sine. Graph the sine, and then you get your U and your N. Wherever the intercepts are, those are your dotted lines. You need those dotted lines right here. Okay, you got to have the dotted lines. That's what makes it right. So if cosecant needs you to graph sine, then what do you think secant needs you to graph? If it was y equals secant x, which one is reciprocal for secant? Cosine. You got to graph cosine first. Now this one is a little trickier, so let me show it to you because cosine only has 2 intercepts because it's a V-shaped curve. So let's look at this one. We know this 2 right here is going to be a horizontal shrink. Okay, that's what that 2 is going to be right there because it's greater than 1. So it's going to shrink horizontally. Horizontal shrink. Okay, so just put that there so you know it. But what we need to graph would be y equals cosine 2x. And this is actually number 1 on your homework. So if you do this first one with me, you've already got number 1 done. You can do this as number 1 if you want to. We got to graph y equals cosine 2x. So what's my a? We need a first. A is absolute value of 1, which is still 1. So that means I'm still going up 1 and I'm still going down 1. That's what that means for my cosine graph. My period is 2 pi divided by 2 because there's a 2 in front of that x. This is my B letter right here, so that's what goes down here. So my period is just going to be pi. My period is pi. So if I go over here, let's say that this second line is pi. That means this would be pi over 2. And then I would need these two other pieces. They would be pi over 4 and 3 pi over 4. You don't have to write them in. You just need to make sure you got 4 equal pieces. It'd be nice for you to know what they are, though. So pi over 4 is here, and 3 pi over 4 is here. You're breaking it into fourths. You're breaking whatever period you come up with into fourths, 4 pieces. Cosine starts at a maximum. So it's going to start up here at the top. It's going to come down to an intercept. We know for a fact that that now has to be a dotted line. Because when cosine is 0, if you flip that over, it's undefined. Can't have it. Then it comes down to a minimum. Comes back up to an intercept. Oh, there's another dotted line. Can't have that one either. And then it ends up at a maximum again. So right now, if I graph this V-shaped curve, all I have is an N here underneath where this dot is right here. I don't have any U's. I could say that I have 2 of them. I have one here, and I also would have one over here, but I don't have any more dotted lines because I don't have any other intercepts. So you're going to actually have to go one more step over, which would be like 5 pi over 4, to show where one more intercept would be. So you kind of have to put a tail on your V just to get one last intercept so we can make that a dotted line too. So you know where your U would go. You need 3 dotted lines for one U and one N. So with cosine, it's a little trickier. You kind of have to go one extra graph to get the next intercept. Okay? So that's secant. Secant, all you need to do is graph cosine. Add one little curve on it. You'll have your 3 intercepts. Get your U and your N. You're done. This was just a question about the shifts and the stretches and stuff. If 2 cosecant x plus pi over 4, then how would that compare to just y equals cosecant of x? This 2 right here would stretch vertically. And this x plus pi over 4 would be a horizontal shift because it's adding just to x. It's a parentheses around the x. You would horizontal shift, and it would be left pi over 4 units. Pi over 4 radians, I should say, actually. Let's go radians. That would be a good idea. Pi over 4 radians. Let me show you why it's left. Okay, if you remember what I told you on the last section, you take the parentheses and you set it equal to 0 because you want to see where you actually are going to start. X plus pi over 4 equals 0. This will tell you where your start is going to be. Okay, so if I solve for x, if I subtract pi over 4 on both sides, you're going to get x equaling negative pi over 4. That means instead of starting at 0, you're going to now start at negative pi over 4. So you had to move left pi over 4 units to start. That's why any addition is going to be a left shift, because when you solve it, you're going to get a negative and you got to move left. So the left will find your 0 point. All right, so that is it for 1/6. Hopefully that makes sense. Hopefully you can find your dotted lines. If you pick anything out of today's, anything, just make sure you find your dotted lines. Because you find those dotted lines, halfway between it will give you your intercept. And then you can just do your curve. But your graph is completely wrong if you don't get the dotted lines right. You got to get those dotted lines.